Hi, my name's Josh, and I'm here today to talk about logarithms and their history. The idea of a logarithm first came about in the 17th century when in 1614 Scotsman John Napier published Mirifici Logarithmorum Canonis Descriptio, or a canonical description of the miraculous logarithms. These were primitively written logarithms, very different to the modern format that Leonard Euler would come up with in 1727, 113 years later. In fact, they were barely recognizable as modern logarithms at all. Euler was also the first person to put in writing that a logarithm is the inverse of its exponent, an idea called exponentiation and essential to the modern theory of logarithms. Let's take a closer look. Let's start with a simple one, the number 1,000. We know that 1,000 equals 10 to the 3, or also equals 10 times 10 times 10. So we can see there are 3 3's, so log base 10 brackets equals 3. Another example is solving log base 216. We know that 2 times 2 is 2 times 2 equals 16. So we count 1, 2, 3, 4. We know, therefore, log 2, 16 must equal 4. This property holds true even for non-whole integers and negative integers. For instance, log base 2 to the half equals minus 1, because 2 to the power of minus 1 equals 1 over 2 to the 1, or 1 over 2. This allows us, with logs, to turn multiplication and division problems into simple addition and subtraction problems. When this property was discovered, logarithms turned hours of tedious navigation calculations into mere minutes of work. Say we wanted to multiply 878,000 562 by 228,936. Now, if we didn't have a modern calculator, all we would have to do was, instead of multiplying these numbers, we would simply add the log of each of them together, assuming both are in the same base log, which for here will be assumed to be base 10. This gives us 5.945 plus 5.360. This gives us 11.305. And all we have to do now is take 10 and raise it to the power of 11.305. This is called the anti-logarithm. And this is because we are working in base 10. And sure enough, the answer matches. Turning multiplication and division problems into addition and subtraction problems allowed the creation of the adding machines that led to the development of the computer you're watching this very video on. So, when the video's over, maybe think of old Euler and John Napier and what they did for us. Thanks.